Hello and welcome to this mathematical explanation of microeconomics and microeconomy. I've uploaded this video because I think it would be a nice addition to the practice you're already getting, but I think maybe you have trouble with some of the mathematics. So this video will show you some difficult mathematical problems. In this case, we're going to look at chapter 3. Chapter 3 looks at what a person will spend, and we're going to look at the problem what a person will spend if it has to choose between two products. So we're going to look at the optimal number of consumption you have of one product given that you look at two products together. Okay. First, some basics. This is an interactive video, meaning you have to do something yourself as well. In this case, for your interactive video to work, you have to turn on the annotations, this thing right here, where the guitar is now. But there's also this vinkje. Turn it on and then we're good to go. Okay. When it's turned on, you will see that at some moments in the video you will get the opportunity to choose either between one or another option. Well, you can do that with this video, but you can also do that with mine. The mathematics might be too difficult for you to immediately see the problem, and the time you have to choose between one or the other might be too short. So that's why I asked you to pause the video every time you have a choice and you think, well, I'm not going to make it in a couple of seconds. So pause the video then, work it out and check whether you had made a right or a wrong decision. Okay, so here we have solve problem 3.7. It's about a Cobb-Douglas function. I will read the question first. Given that Julia has a Cobb-Douglas utility function u equals q1 to the power a, q2 to the power 1 minus a, what share of her budget does she spend on q1 and q2 in terms of her income? 1, prices 2, and the positive constant a. So we have three elements, right? So we'll have to deal with all these three elements and make some type of optimization. That's the whole thing, right? So before we going to delve into this optimization thing and how income comes into play, I first want to look at this utility function. So what's the interesting thing about the Cobb-Douglas function? I want to hypothetically rewrite the utility function q1 and q2. Okay, so what we've got here is this utility of q1 to the power a times q2 divided by q2 to the power a. Wait, is that correct? Or maybe that's a better one. Utility equals q1 to the power a times q2 minus q2 to the power a. Okay, I'll leave it up to you to guess or to know which one is correct. Pick one of either two, and if you picked one, we'll continue and I'll tell you whether it's right or wrong. So, some exciting music. I don't have a budget, sorry. No budget. Okay, so no exciting music. Option B, unfortunately for you, incorrectly. But let me explain why it is incorrect, because I think this is important. It's because of the powers, right? It's confusing. So, because we have letters and we don't have numbers, let's simply take numbers and look what happens, okay? So if in doubt, take some numbers and you'll see what happens. We'll do this here as well. We'll take for A, we'll take a half, because that's easy. And q1 doesn't matter, right? q1 and q1 is equal in the formula, so I'm ignoring that one. It's about the q2, of course. That's changed. So this q2 will take 1/4. Okay. If I make this part, so q2 to the power 1 minus alpha, we'll rewrite that into numbers. So q2 is now 1/4. 1/4 into brackets to the power 1 minus a half. 1 minus 1/2. Okay, so that's actually similar to 1 quarter to the power minus 1/2. Okay, put it into brackets again. 1 quarter to the power minus 1/2 is equal to 4 to the power 1/2. Okay, so it's 1 divided by 4 multiplied, or to the power minus 1 minus 1/2 is similar to, or is equal to 4 to the power half. Okay, 4 to the power 1/2 is actually 2. Okay, so we know that q2 to the power 1 minus alpha, in this case with these numbers, is actually 2. Let's remove the whole thing. So now we know it's 2. Okay, we'll take the other version. So now we have q2 minus q2 to the power a. This is actually q2 is 1 quarter, and q2 minus q2 to the power a equals 1 quarter to the power 1/2. And this is actually 1 quarter minus 1 quarter. Oh, minus 1 quarter equals 0. So this was 2, and here we get a 0. So unfortunately incorrect. Now you'll see the correct version. You've guessed correctly. A was the correct answer. Why? Well, I think it's obvious, but let's explain it anyway quickly. So we have this q2 to the power 1 minus a. We ignore the q1 because that's simply the same. q2 to the power 1 minus a equals q1 times q2 minus a, right? We can just split them up. This is acceptable. If we have a negative power, we could also write it as below the bracket without the minus. So we get q2 to the power 1. So q2 a. Okay, you'll get the point. So I started afresh with the utility function, and the first thing I want to do is add the budget constraint. So instead of simply writing the utility function, we add the budget constraint, and then we call this thing the Lagrange. So we add the budget constraint plus the lambda. Lambda is the sign normally used for designating the budget. And here we get our income of, what was her? Julia. And it consists, of course, of the price of apples and the price of bananas. Okay, so this is our entire budget constraint. Now what do we have to do? We have to optimize our formula, right? Because optimization leads to the most efficient outcome, of course, and optimization is simply taking the derivative and we set it equal to 0. That's the whole thing we need to do. If we done this, then the rest is a done deal. We simply have to think of what we want to explain. But if you see an assignment like this, always think, okay, optimization, derivative, set it to 0. Okay, I'm going to make some room. So we know what we have to set to 0. Change the color black to black. Okay, and now we get 3 first order conditions. We get the first order condition that lambda with respect to q1 equals 0. We get the first order condition that lambda with respect to q2 equals to 0. And we get the third one, oh, that's no q, that's the lambda, of course, with respect to lambda also has to be equal to 0, because we need some room for our derivatives. We're going to look first only at step 1 at the q1. and I'll ask you again to make a decision between A and B. Okay, so it's up to you. You have to choose, of course. I hope I can make this nice for you to click on. I have nothing to do because I have no money for waiting music, so we'll just wait here. And if you made a choice, we'll see if it was the correct one or not. Okay, you were on the right track, but not completely. I'll show you what went wrong. Okay, so the Lagrange is simply the derivative of Q1. You've got that completely right. However, this part, so the Q2, because this is simply a partial derivative, I will explicitly write it out. So the Lagrange of Q1, we can also say this is the partial derivative of Lagrange with respect to the partial Q1. Okay, so for that we need this part, but this is simply a number. It's saying 2 or 5 or whatever. So we have to add this simply as if it is just a number. So what we do is, let's remove this whole part. Okay, we'll cheat a bit because it's a computer, of course. Let's move it over a bit here. And we'll add this part. Simply add it, copy, and paste, right? This is the correct formula, because this is just a number. We ignore the rest of it, and then we get the whole formula. Here we have the correct version. Let's remove the incorrect part. Because we have this part, now we can do the other one as well, right? So the Lagrange with respect to Q2, similar thing, right? We have, okay, this is again just a number, right? Q1 to the power A, and Q2 is not a number. We have to take the derivative of that one. So this one goes in front, 1 minus A, between brackets, right? And then Q2, 1 minus A minus 1. Okay, and the second part, lambda y P1 Q1, nope, here, okay, here we have the Q2, so that's P2, lambda P2, lambda P2, and what did I do wrong? Yes, nope, like that, right, minus sign. Okay, I've shrunk them down because of space. Okay, but now we see here the partial derivatives of Lagrange with respect to Q1 and Q2. Remember, these are equal to 0 because we're optimizing, right? Having the maximum means we have an optimum. So equal to 0 it is. We remove that because of space, but okay, we get this. And what we now can do is this part, there's a minus in front of it, so we can take that to the other side of the 0. So we get lambda P1 equals a Q1 to the power A minus 1, Q2 to the power 1 minus A. We can actually rewrite this, lambda P1, and then we equal it to A, Q1 to the power minus 1. And then let's see what we have left, right? This minus 1 is gone now. And now we have Q1 to the power A and Q2 1 to the power minus A, 1 minus A. Okay. Remember, this was our original formula, right? Q1 to the power A, Q2 to the power 1 minus A. So what we can simply say is we multiply this by U. Done? Okay. We can do the same for lambda P2. And now we get 1 minus A, of course, instead of the A. Let's see, okay, the Q1 to the power A, and then we have here Q2 to the power 1 minus A minus 1. Okay, so here we get Q2 minus 1 times U. Okay, here, let's put lambda equals A Q1 to the power, A U divided by Q1 P1, right? P1 to the other side, we divide, excellent. And here we get lambda equals 1 minus A U divided by Q2 P2. Great. So I cleaned the sheet up a bit. Now I've only got the lambdas left, and the lambdas are equal to each other. So lambda equals lambda, right? So I can equalize one formula to the other one. And I'm lazy, so I don't rewrite. I just delete and that sort of stuff. Okay, so here we are. We have equalized these two formulas to each other. And now the question to you, which of the following formulas is the correct one? So I'm going to rewrite these two equations to each other, and then it's up to you to say which one is correct. Okay, so I'll give you two options. Okay, I'll give you a couple of minutes to, no, not minutes, seconds to think about it. If you don't have enough seconds, then please pause the video and continue when you have the answer. Click either one if you're a gambler. I don't know what more to say. I think this should be time enough. Unfortunately, A is completely incorrect. Okay, so B completely correct. Why? Fairly simple. First, remove the U's because they're on both sides, right? So they cancel out. Then we're left with A on this side, 1 minus A on that side. We divide by this, okay? And to get that one on the other side, we'll multiply. Simple. Okay, so how do we continue? We have this third condition of the first order conditions, namely that our budget P1 Q1 minus P2 Q2 is also 0, and we have to use all three formulas to get to the most efficient outcome, right? I'll remove the equal 0 again because of constraints in the size. Okay, so we've got this formula, right? And we almost have the correct formula here, right? To input either P1 Q1 or P2 Q2. Well, it doesn't really matter which one you pick. We'll just pick one and well, hope for the best. My hopes are on Q1 P1, so I'll say let's rewrite this, and then we'll get Q1 P1 equals we got this A 1 minus A, and then we have to have this on the other side, so we multiply by Q2 P2. It almost fits, right? So let's rewrite this one. So the Y is there, minus P1 Q1 will enter this, so A divided by 1 minus A, multiplied by Q2 P2, and then minus P2 Q2. The order is changed. Okay, so now the question to you, which one of the following two is correct? So A, either this one, or B, this one. That's a difficult one, right? Yeah, that's an A. Still not really nice A. I'm still letting you think here, right? So some waiting music. I think you need longer for this one, so please pause it, and if you think you have it, click one, A or B, and we'll continue with the next part, the final part, I hope. Okay. Unfortunately, A is incorrect, and I'll show you why. Okay, so we'll start with having Y over to the other side. So Y equals, and what do we get here? So this Y was a plus, So actually what we did was we took this whole part, these two, we took that to the other side. So the first term becomes positive where it was negative, Q2, P2. And the other term, the second term, also becomes positive, right? This becomes positive because to remove it here, we add this term here and we add it to the other side. Okay, and we do the same for you. So we add to this side and it's gone, and we add to the other side. So here we get also Q2, P2. Okay, easy. Now, how do we get this Q2, P2? And then something in brackets. How do we do that? Okay, the first one has A divided by 1 minus A. Okay, and the other one, we simply add 1 plus 1 time Q2, P2. This is correct, right? And that equals Y. We'll believe that. But this 1, what can we do with it? This is a real nice trick. So we still have 1, but we now call it differently. We call it we call it 1 minus A divided by 1 minus A. 1 minus A divided by 1, that's 1, right? So now we still have 1 in this part. So this one is this one. Yeah. Okay, and now we can combine it. I'll remove this one because now we don't need it anymore. And we'll combine that one. So we write Y equals Q2, P2. And now we get something in brackets because these two have the same denominator. Right, so we get A plus 1 minus A divided by 1 minus A. Wait a second. A plus 1 minus A. So A minus A. These drop out, right? So now we get 1 divided by 1 minus A. And this was answer B. Answer B was correct. We'll remove this one. And continue our struggle for a complete answer. What we want to do is we want to rewrite to P2. Okay, it doesn't seem too difficult now, right? What do we have to do? Let's rewrite this one. I'll simply put the Q2 on top. So remove this one, and then Q2, you go here, and then you, yeah, like that. Okay. How do we get this part to the other side? Well, that should be easy enough. So P2 equals Y times 1 minus A divided by Q2. And this is actually the answer. We can do the same for P1. I'm not going to write it down, or I'm not going to show it, but then we get the same thing. We get Y A divided by Q1. Okay, so finally they also ask for shares. Shares of their consumption. So the share of one was apples, so Julie's shares of apples equals the price of one of apples times the quantity of apples divided by Y, right? This is your budget, and this is what you devote to apples, and the other part will be bananas. Okay, we're not interested in bananas right now. Let's rewrite this a bit. So we get share of 1 multiplied by Y, and then we get a clean P1 times Q1 here. Okay, and this is interesting because now we have this optimal thing, right? Let's simply copy it and drop it here. So this is the optimal price you're willing to pay for your apples, and let's combine it. Okay, so here we have S1 multiplied by Y equals, and now for P1 we enter this. So we get Y A divided by Q1, and this is multiplied by Q1. 1. Okay, and now some stuff drops out. Let's see what drops out. So the Y is on both sides, gone. Okay, and Q1 also here, dividing here, it's gone. Okay, so great. What we are left with is very simple. The share in a Cobb-Douglas function. Nope. Maybe drop it down a bit. Okay, let's make it bigger, and now let's drop it down. So the share of 1, so the share of apples is equal to A. And well, then we'll make the story complete. What will be the share of 2? Share of 2 will definitely be 1 minus A. That's the whole story. Thank you for your attention, and I hope you liked it. Please let us know what you think about this video. Below you have some feedback. I think I'm not sure how I'm going to make that, but please comment on the video or fill in the feedback. Thank you. Bye bye.